who am I? My name is Matt Austin. I'm Director of Security Research at Contrast Security. I've been doing AppSec for around 8 years now, and it's been most of my spare time doing bug bounty hunting, things like that. So I want to talk about the desktop web, and this is a term I believe I've made up, but that's okay too. And so when I talk about the desktop web, there's a few different flavors that I consider. There are basically web applications that are, it's a desktop application that is just a wrapper around a web application. So if you look at Slack, all it really does is some basic notification, things like that, some light desktop integration, but overall it's loading the web page inside of a frame. But you want the desktop integration, right? You want to like have the presence, have the notifications, have the video, record, things like that you have to have from the desktop. So that's a pretty common approach. But recently we've come across a lot of IDEs, and they're also completely built in these web languages. So Visual Studio Code, Atom Editor, things like that. So we have frameworks like Electron, and that's what Visual Studio Code's built on. It's released by, I think it's a GitHub project, and so their Atom Editor is also built on top of that. And there's other ones like NWJS, I think it became before Electron, and then there are frameworks like MacGap, which just similar type of web bridge framework. And then there's native web or mobile applications, and they come in a couple of different varieties as well. You have either another embedded WebKit window, or you have these like React Native, where you write web technologies, but it makes native components, and there's some bridge there. And then there are other apps, like another classification of apps to me, and those are like, let's say, Eclipse, for example. It has different things that render in HTML, and so they embed WebKit, but it's not their primary window. That's not their primary view. And so this talk is going to cover hopefully a range of those. It's easy to pick on Electron and its security, but there are different problems that you can have with different types of embedded browser and different types of desktop web applications. So exploiting the desktop web, I personally don't know assembly very well and am not that great at reverse engineering. So I'm an AppSec guy. I've been doing AppSec for a really long time, and this is really interesting to me because you are using just the basic web technologies, web hacking methodologies to attack a desktop web application. So, and there's a bunch of interesting questions, like what is same origin policy of a desktop app? You're not visiting a URL. What policy should it have? And then there are really, really interesting consequences. Like if I can execute JavaScript, sometimes that can turn into remote code execution. In a lot of cases, that can turn into remote code execution. So this slide is hopefully unnecessary, but just a quick. So what is Markdown? And I'm using it. MarkDoom is the title. So it's basically we're exploiting Markdown to get this JavaScript injection. So if you preview a Markdown page and it can execute code, can we execute remote code? Can we take over your desktop because you previewed a text file? And so Markdown is a format like syntax language that just does basic formatting. So a bold, underline, things like that. I'm sure you're all familiar with it. It's common on GitHub and Bitbucket and documentation. Like most projects have documentation in Markdown. So and there's also blog platforms, which I am a fan of. You write your blog in really basic formatting and get this rendered HTML output. So that's kind of the thing. All Markdown parsers take in this basic format, like the first example here, and convert it to HTML tags. So it makes sense for a lot of these renderers, whether they're native applications or not, to embed WebKit or to embed some browser renderer in order to show the output, because most of the Markdown parsers end up rendering HTML. So why is it so hackable? There's not a lot of official spec for Markdown, but any of the specs that you read or any of the markdown parsers that you handle, there's one last thing that says if you can't format it with markdown, just drop into HTML and write HTML. And so I think that's why all the parsers like fall back to HTML, because there's kind of this exception that like, you know, whatever's left, whatever you can't do, we don't want to provide an ongoing spec, so, you know, use HTML. And I think that that's really interesting and becomes a problem. Like, you know, normally you would expect markdown files just to be basic font and highlight and headings and stuff like that. But what happens when I put an iframe into a markdown file and preview it? And in a lot of cases, then you have an embedded iframe. And so, you know, I think there is kind of a question is, like, if I preview an HTML file on my desktop, it also shouldn't execute code, right? So even if you're saying like maybe you shouldn't be previewing a markdown file that you don't trust, at the end of the day, it's still supposed to be just a viewable file, right? Like Word documents aren't supposed to execute code, and when they do, this is like a dangerous pattern that we should avoid. A lot of these techniques though, so I'm talking about Markdown and Markdown editors and all of the IDEs, but there are many applications that have embedded browsers for different reasons, like Slack or like these other applications, and all of these things apply. And so, you know, picking on Markdown or picking on IDEs, you really just want to think about, is there an embedded browser, and can I control code that gets there? And if so, can we exploit that to code execution? So in this context, and we're talking about IDEs, you know, who did it wrong? What was successful? So there was a problem with Visual Studio Code, GitHub's Atom Editor, Adobe Brackets. Eclipse had some interesting issues, remote code execution in TextMate, which is interesting because it's a native app and really lightweight. JetBrains suite, and if you don't know the JetBrains suite, it's pretty robust. There's a lot of those. And then there was a section of just Markdown editors that are just designed as Markdown preview and editors. And those are, you know, maybe less common, but I believe Markdown is really common if an editor doesn't have a preview mode. They're usually designed to spawn that application to do with rendering. So, like I said before, Electron is a framework that allows you to write web and HTML, and their slogan is, if you can build a website, you can build an application. Maybe it's a little strong, but if you can hack a website, you can definitely hack a desktop application. This is going to go a little bit off topic, but I want to talk about a CVE that's directly in Electron, and it really has nothing to do with the IDEs. This came out like 2 days ago, so I wanted to cover it really quick. And this is like universal, any application that uses Electron. There's a couple of caveats, like it has to use a custom protocol handler. So if you think about Skype or Discord or any of those applications, they're all built on Electron, and there's even like a Bitcoin wallet, which is kind of terrifying. But they register a protocol handler so that web pages can invoke and open them. And there's a flaw in all Electron apps where if you register this protocol handler, the way it was registered in Windows led to code execution. And so if by chance you trust Slack and say, or Skype and say always open because I know this application, then a website could inject some JavaScript into the page that would, you know, make this execute. They didn't give many details in the CVE, so I decided to look through the code change, and there were a lot of changes in this thing, but at the bottom of it I found a test case, which is super handy if you're trying to look for vulnerabilities, just see what they're testing to not do. And so it really ended up as simple as you put, you know, a JavaScript tag with this on it, and the Exodus is the Bitcoin wallet, and that'll open the calculator on the local computer. And it comes down to like the way Electron handles the parameters that are passed into the URL, and then it respawns Electron, and so all of your parameters are together. And Electron is actually, you know, an embedded Chrome, and so all of the Chrome arguments are also available to be passed in. And so there was some confusion there. And now they explicitly exclude a bunch of the Chrome arguments that are unsafe, and I believe they also use -- to pass along. And yeah, they recommend if you can't update your own Electron applications right away to add this switch if you can't bump Electron to the newest version. As an end user though, it means that you should update every application that is built on Electron, because it's not like updating Java or updating Flash. Everyone has its own copy of, so just Discord and Slack, they both have the issue, and updating one doesn't magically fix the framework for you. So to get back on track a little bit, abusing Electron. So Electron is a Chrome renderer, and it has Node behind it. And so you can write code in Node, then you can embed a window, a frame that loads all of your viewpoints and everything. And then there's actually a like node integrations. So all of the node globals are passed into the web window, which is super dangerous if you think about it, because Node itself can, anything Node can do, this web window can do. And there's a flag you can send to your embedded web window to say it can't access Node. But I mean, that's kind of the point. These sites want to, embed it, use Node to do a desktop notification, so they enable it and assume that you'll never have remote user code on this page. So, Visual Studio Code, GitHub, brackets, they all use Electron. And so, really, when I started playing with this, I didn't expect it to be this simple. And so I open up Visual Studio Code, I add a script tag, and then I know a little bit of Node.js. I know that child process can be used to open another application on your desktop. And sure enough, it popped open a calculator. It was actually quite shocking. So I reached out to them and talked to them, and they added a couple of fixes. They ended up embedding content security policy into the site, which is great and interesting. They also had an exception. I guess they assumed that, executing JavaScript in an unsafe way based on their prescribed stuff here was not always what the user wanted. So they pop open a dialog when there's a CSP violation, and the user can opt out of that, which also kind of has its own inherent problems because it ended up being in the DOM that you also control still, so it didn't help much. So how can we get around this? So CSP at the time, I'm not sure when this is resolved or not, but content security policy is designed to prevent you from, from having things injected into your site or executing script in context or whatever. But it doesn't really care if you go to a different page. But that's kind of a problem for us because the content security policy was injected into the top of the page above our code as this metadata. So we're talking to, it's a locally rendered website. There's no URL that it's hitting or socket that it's hitting or anything else. So that's kind of a big problem. There's everything, all the content security policy has to come from the document that the user is controlling or that the attacker is controlling. So meta redirects aren't controlled by that. So even though we don't have JavaScript execution yet, we can meta redirect to another site in this browser preview window. And now because they don't control the top of our document anymore because we shifted away to a domain we control, we won't set our own CSP, and then we can get this remote code execution again. And so, yeah, there's a couple different variants of it, and then in the end, it ends up being the same thing on our new site, our remote code execution HTML on the remote site. That's how we render that. So how do they fix this problem? There's a couple of things you can do in Electron to explicitly say, I don't want you to navigate to a new page. So I don't want meta redirects. I don't want you to click on a form or a link or anything else. Anytime you're going to navigate to a new window, don't allow that. They also finally disabled known integrations on the window, which is awesome. If you need to interact with Node, you can use post message and some other internal services, and you can, there are better ways to do it. You shouldn't just allow the browser to have everything Node can do. So really similar with GitHub's Atom editor. So really similar. It had some basic things around like what you can and can't do, but we could embed an iframe. In that iframe, messing around with this, I made an HTML page, and in that page, I had the same JavaScript and it executes. And that's all well and good, but there was a problem where I couldn't give it a remote path. So that path to RCE, like I'm not on your computer, or I don't control any other files theoretically on your computer. So how can we execute this? And it turns out that if you create an unauthenticated or an anonymous NFS or SMB share, and typically those live on a network, but those can be remote and you can just expose them to the world, which I wouldn't recommend doing unless you're trying to be nefarious. But it actually auto mounts. So when I embed this iframe to this file location, and now we're talking about like the same origin policy, because the renderer for the markdown preview is on file:// and if I go to this remote IP address, it auto mounts to this net directory on Mac, and then it's a similar path on Windows. And so my remote server is now in a folder location on your computer that I know of. So now I control an HTML file that technically lives locally on disk. And so that worked well. And then my remote/local script is doing the same thing we had before. They've actually had another problem since then. I don't remember what exactly fixes they had in place for mine. They had another remote code execution fairly recently that someone else did. And since then, looking at the mitigations that they do, they've enabled CSP. They disabled node integrations, which was key. And they also use DOM Purify, which is a library that allows you to strip out HTML and whatever, kind of, which is much better. Seems like it would be great. There's Adobe Brackets. It's really similar, except that it actually technically doesn't use Electron. And so same approach overall, the same file:/ approach. It just has this custom integration. It had an embedded brackets thing, and you had to connect to a module to get access to Node. It's a little more complex, but overall the same. Once you get your Node object by creating a fake plugin object, you can execute code. So the next part is maybe a bit more interesting because this affects things that aren't necessarily Electron applications, right? So if you just have an embedded web browser and there's no Node integrations, if I have JavaScript access, what does that mean? It's an embedded browser on a page, but like it doesn't automatically guarantee remote code execution. But the question is, so if I have something like Slack or Yammer or something like that, and I send you a URL, if you click on it, you don't want it to render in the little chat preview window. Like that doesn't make a lot of sense. You want it to open in the user's default browser. But how do you know what the user's default browser is? It's a little bit interesting because there's not great reliable ways to necessarily, you have to build it for every OS you support, and you have to keep that up, and figuring out the remote browser is not always the easiest thing to do, so no one does it at all. Instead, you just ask the operating system and say, hey, how would you open example.com? And normally it says like Firefox or Chrome or whatever else. And if you said, how do you open example.com, whatever.gif, it would still use your browser because you gave it an HTTP URL. What's interesting is if you send, hey, operating system, how would you open this file:/ URL and give it a full path to something? And we, like full path to calculator.app. It doesn't open it in your default renderer. It actually opens it it just opens it. It just executes it. If you send it a file path to a Word document, it would just open that Word document. It would open it in Word or whatever you had installed as the default editor. So by design, it's using like a built-in, on OS X, it's using like a system open, or it's using command exe/c or whatever it is. Windows, I'm not as familiar. But overall, it's just sending it to an open command, which isn't great. But again, so we have the same problem we had before, where we can't open local files, but we learned a trick for that. And the other problem is the file must be executable. But if it's a local file, when it comes to remote, it's not always executable. I can't do +X and have it live locally for you, so we end up running into another sort of problem. It's an unsigned binary, or it's not executable if it comes from certain, origins. So how do we work around that? And so sure, we can open up the local calculator, which is great for demos, by the way, but it's not great for, that's not the attacker's objective, right? It turns out that you can actually create an app file, a .app file, which is a standard macOS application file, by writing AppleScript. And when you compile that, in the AppleScript editor, you can do anything in there. It's just a basic scripting language, and you can do anything in there. And when you push the button to compile that, you can export it as an app file. The thing is, it's not actually creating a binary. It's creating an app. It's just this package, and it's just executing your AppleScript. So it opens automatically, but there's no signed binary. There's no permission issues or anything else, because it's not actually an executable, right? It's not a binary. It just happens to open automatically and execute your script. I found that out a little bit later, and one of the tricks I was using before that was OS X terminal has a .terminal file. So the other thing you can do is just say, are there any applications on my computer that when, the default behavior for this file type is to run the file without it having +execute. So come to find out, there's a file called a .terminal file, and it's to export your preferences for terminal. And so, your background colors and all of that. But one of the things you can have in there is a startup command. And when the terminal opens, it'll just run this command every single time. And so you can create this terminal file, export it, and then when it's open, it will run whatever code you had in that block, that open on startup block. So that was great. And we use that on Markdown and a few other ones, but also in things like Sublime Text, which are definitely not built on browser technology. It's just that the preview window for Markdown, and even though it has no necessarily unsafe integrations, the default behavior for opening this .app file is to execute it. And because it's not a binary, it happily executes it. And because it's actually in a file colon path, gatekeeper, which usually blocks you from executing things you've downloaded from the internet, it doesn't believe that this is remote because it lives on /net/whatever directory. So that's not very, very good. So the other thing we can take advantage of is a JavaScript bridge. A lot of the applications, like JetBrains and things like that, they have a similar approach. They don't have Node built in, but they have integrations where they have some Java on the client application side that they can invoke from the web application itself. So, and then those have API calls to do different things. So we can abuse the same open an external browser because it's typically done in an unsafe way, but we can invoke it directly with the string we control, and we can bypass the validation that they had in their renderer for your HTML links, which is great. There's a few ways to find these. So this was great for JetBrains because there are open source versions of some of their products, and a lot of the interactions are all easy to find. Most Electron apps package an ASAR file, which is just basically this zip format that they support, but there's an easy way to extract those and then go through the source. And then if not, if you have JavaScript execution, it's pretty trivial to do document.write to dump out, list all the objects that aren't part of a normal window, and from those give me all of the functions that I can invoke. One of the integrations that was most shocking to me was TextMate. TextMate just had a system command, and the system command just ran whatever you put into it. It was kind of interesting on this one because this is also available through their HTML preview window. So if you are editing an HTML file and want to see what it looks like, or if you happen to open an HTML file that is malicious and clicked preview, it could just call system calls. There's another issue with TextMate where you could automatically invoke preview from a web URL, so you could force that to happen. You don't actually have to preview a file. So that's the calculator there. And another one that was kind of interesting, and it was the third bypass for Visual Studio Code. And I wasn't necessarily trying to pick on them. They were just the first one and the one I used myself the most. So I thought it was kind of interesting. So there's the external protocol handlers or schema handlers that applications that I talked about earlier with the CVE. But internally, they're also used, and they're not exposed to the greater OS, but internally, if I click on a link and it calls this thing, how does the application interact or execute? And these are everywhere. I mean, Eclipse has a lot of built-in ones that open up different panels or hide or show different things, all based on these like URL schemas. So Visual Studio Code in your rendered web thing, after they fixed all of their CSP and all the other problems that they had, they still allowed you to create these Visual Studio Code. And this is basically just invoking a debugger and setting its type to node, and then passing an arg-e just says evaluate anything else I passed the command line, and then we have our normal, our payload from before to execute code in the node context. So that was another unfortunate easy bypass for them. So what if they're doing everything correctly? What if there are no external files? Or what if there's no like external interface like Node or something else to interact with? It's really locked down like it should be. There's no bridge that you can exploit. What else can we do? Most of these render themselves, they have like some base HTML and then they render into that and they load that from disk, right? So they're loading this preview HTML base from disk, and so it's file : /. So the origin of this window is a file origin. That means that we can read any other file from disk that is of that same origin. So what happens if we read, like Etsy password or Etsy hosts, or what if we read your SSH keys from your local directory? And then we can send those because we're a file origin. Most browsers it's kind of privileged, so file can go out, but you can't go down to file. So file can call out to evil site, and you control the CORS headers for evil site, so you can allow that request to come out. And this happened in Eclipse, which was kind of interesting. And there was a little bit of talk around this bug, and I don't believe that they think that it's an issue. So this is still available in Eclipse if you happen to have someone preview a file for you. That came out kind of horrible. But the other interesting thing in Eclipse, which doesn't have to do with Markdown, is Java docs. So Java docs are just how you comment. They're just comments that describe your classes and things like that. But they're actually used to, give you type information and things like that in your IDE, or to automatically, as you type a method name, to give you type completion and stuff like that. That supports HTML, and it's crazy because it actually only supports a pretty limited subset of HTML when you preview it. And so I created an image tag, and it would preview the image tag, but it wouldn't preview the iframe, right? So looking through, there's a super small subset of HTML tags that it supports, pretty basic formatting. I don't know that big images and stuff are very useful either, so maybe they should limit that some more. But what is interesting is if you mouse over the method name in the code editor, it tries to pop up another window that shows you your Java docs, right? So it's showing you the method signatures and all that, trying to show you that in line. And that's not the same renderer that's down here. And that ends up, for some reason, just popping up a brand new window that's an embedded browser, and it has a wider range of HTML that it supports, including being able to read local files and send them along. So a few other things that I look for when I'm looking for apps. JetBrains had a few more bypasses as well. They had a built-in API, like a built-in local server running on a random port, and it had a key that you had to use to interface with it. But because I could read local files, I could get the key, and then once I had the key from the local file, I could make calls to like open a project, and then that project could have an auto start script in it, and then it could execute. So there are plenty of other bypasses and ways around these things. So look for open ports, look for open, any other things, any daemons they run, things like that. Looking at the rendered code was really fun because the Markdown editor, there are ways to bypass like its format and its handling. Like if I create a link, but it has a double quote in it, how good is your Markdown renderer? Is it gonna break out of the HTML tags or not? A deprecated but still available everywhere tag is the XMP tag, and it will just show HTML of everything under it. It's like the pre-tag is supposed to be for formatting, but it actually just dumps all of the rest of HTML. So you can see if there's any new JavaScript injected below you, which happens a lot, or you can see like how exactly it's rendering if you're messing up HTML tags by breaking Markdown's parser. And so, so Markdown files also, I needed to know the path that the application was opened in, and that wasn't always resolvable. But if I did a relative link to a file, you could read the URL from the relative link. That was handy. And Electron also has a flag that you can pass, which is --inspect, and then you can use Chrome's remote debugger to completely, analyze everything you're doing there, just like you would a normal web page. And most apps don't block that. I think it happens before an application starts. So if you were trying to find issues in an Electron app that you don't have the source to, that can be a really super handy feature. I wanted to show basically what not to do by example. I didn't create a checklist or a list of like, this is the right way to do it. A couple of people have though, and I definitely wanted to call them out. Luca, sorry, I'm not gonna try. He did a really good talk at Black Hat this year, and he has a new great checklist for Electron that covers a really wide range. He actually found a few CVEs in Electron as well, and so if you can find his stuff, it's really super interesting. And Electron has their own security README. There are some definite issues with that README and some of their advice, but overall, it's definitely something you should try to follow. I have a lot more details about each of these. I'll be posting them now as soon as this is over. And if you have any other questions or comments, I'll be happy to take those. But if you can't find me afterwards or now, you can find me on Twitter. And I went short. So any questions, anyone?
So with the part of this where you're talking about, okay, so depending on a file extension or a file type, it's going to be automatically opened in some particular way based on the operating system. Does that require user interaction? So if I set an anchor tag that points to a file, do I need them to click on it, or can I use like a web frame redirect to open that as well? So
that depends on the embedded browser and how it handles it. So there were times where I had JavaScript. I could execute JavaScript, but there was no integration I could abuse to get remote code execution. But I could embed a URL and then force the JavaScript to click the link. But there are also tricks like, if it's in an iframe, what do you do with that? Or if I meta redirect to it, what do you do with that? Or if it's if I set the target for a link or for a form, and then there were, you can make forms kind of auto submit different ways, or make it invisible and big, so all you have to do is click at the document, right? So, it might require some user interaction, but there are definitely styling things. I mean, at the end of the day, you're playing with just HTML, and getting a single click for code execution isn't horrible, but most of the time when I fall back to this, I have JavaScript already, but I just can't do anything with it, and that's when I trigger.
Cool.
This one up front.
What would an exploit scenario look like? Like, would you just send developer code and?
Yeah, so that's fair. And to be, a bit honest, like, yeah, so you're assuming someone's looking at your malicious Markdown file and previewing it. In my opinion, I don't think it should execute, right? Like, I definitely don't think it should execute code, and that's kind of where I started as a base for this. If you're doing malware analysis or looking at an open source project and it wants to be malicious, I think that's like a reasonable sort of attack scenario. And a lot of the IDEs have preview automatically next to it as soon as you open it. And so, or if you've ever previewed one, any one you open keeps the preview window open. And so that was a little bit annoying. I wanted to reiterate though that I picked on these because there were a lot of them and they had a few different approaches as IDEs. But I found there's a remote execution in WordPress desktop editor, and it's a really similar approach, a really similar attack. And yeah, they have some desktop app that lets you edit it, and they have a weird remote interaction. And if all I have to do is invite you to edit my site, and if you click on it, it'll execute. If you think about all of your chat apps or your desktop, like if you look at Yammer or if you look at Slack and those things, like any one web vulnerability, any JavaScript that you can inject or HTML that you can inject potentially could be.
So if you had an XSS in Slack.
Yeah, an XSS is like most likely will result in this. There's definitely things they could do to avoid it, like disabling protocol handlers like the file protocol handler before you do a system navigate, or actually figuring out what your default browser is and just telling everything to open in the browser. And definitely disabling node integrations and all of the best practices that you should do. But more than likely, yes, if there's a desktop application that is built around Electron, you probably can find code execution.
I had 2 questions. First off, the remote mounting where you were able to do file and then a network path, and then on the Mac it would like show up as a mounted drive. Is that something you can do for a host that's not on the local network?
Yeah, all of my examples were a server I have on DigitalOcean or whatever. So,
okay, cool.
And they automatically mount the same just by IP address and auto mount. And it's the same thing for Windows SMB mount. So you can do both platforms.
Cool. And then also, like, you created the .app file. How would you deliver that to the client machine to execute?
The same way, through this remote SMB, right? So I give you whatever you're trying to preview, just the markdown file, and then we use the link click to force the click, and the full path for that clicked file is the SMB : / whatever to the .app file or to the .terminal file.
Does Windows have a similar exploit?
I'm sure it does. There's definitely a bunch of file formats that I was going through a few lists that are intentionally blocked by Outlook and things like that. Like don't allow these, and those all seem like great candidates for things that open weird things like help files open locally on Windows, and then what privileges does a local help file have versus a remote like HTML file in a browser. So definitely, there are definitely some avenues. I use a Mac and hate parallels, so I don't end up there a lot. But I tried to reproduce as many of these as I could in Windows and use the same SMB tricks to get there. Is that it? Great. Thank you.